For our optimization project, my group was myself, Schraven, Duncan, and Pearson. For exercise 8.6.2, we were trying to prove that the n sub star was equal to the n sub t plus 1 after we plugged this into this model. So if no harvesting was being completed, then all of the values n sub t minus 8 and n sub t were set equal to n sub star. And then once you go through this handy equation right here, n sub t plus 1 is found to be equal to n sub star. For exercise 8.6.3, the model was set so that the populations were scaled to the fraction of their carrying capacity, and then once you go through that, the C of t was plugged in, and then that was plugged into the new rescaled equation as well as the original equation. And then this model right here represents the 2% of the adult female whale population being harvested each year. And then the 9.4 parameters act as percentages of female whales that produced offspring. The other adult whales could have died or simply not reproduced. The 0.94 population shows the direct correlation between the number of females reproducing and the number of whales being harvested. For exercise 8.6.4, the fecundity was found, and this was done by taking the original fecundity provided, and then the n sub t minus 8 value was isolated. And then this is the work right here. Right there. Right there. And then on exercise 8.6.5, for the first part, the A section, a new constant was set forth, which was n sub e into all of the adult female populations, and then C sub t was set to be C for a constant, and then once this was worked out through this equation right here, we found the value of C, which can be used to graph, which is a new rescaled equation that correlates the population of adult female whales being harvested. And then on this next slide, right here, a point on the graph of C of n of e was worked through so that the tangent of the graph was horizontal, and then this is the only critical point that has a slope of 0, which is x equals 6.001, y equals 0.0255. Let me double check that real quick. Yes, and then so x equals 0.6.0255. I have more graphs attached to this video, which I will get around to. And then, so the derivative of x at this graph is 0.60001, which correlates to the maximum possible adult female reproducing whales that will be discovered. And then we discovered that when the harvest rate is 0, the female reproducing whale population will be at its max capacity for the environment, which is outlined in this paragraph and the preceding equations. And then the max the max value that C will have that leads to equilibrium is walked through in this problem right here, and we got a value that was supposed to be around 6,000, which this is pretty darn close. I like that value. Got 6,379.089. And then this is the Desmos graph that was used to graph our original function, which was from 8.6.3, where 8.6.4, which C was isolated in terms of n sub e, and then got the original graph right here. You can see the critical point, the max, which is right here. We got 0.6, 0.0255, first derivative graph right here, which shows that which intersects also at 0.6 x value. And now back to the original thing provided. We are supposed to say where the derivative is 0, and that is at x equals 0.6. That is the horizontal tangent line is completely flat. And then the derivative in this sense is defined at all points on the interval, which is bracket 0, comma, positive infinity. And then the endpoints of the graph would be 0, 0, x 0, y 0, and then there is no right endpoint. It continues on to infinity. And then the values for the critical points were determined using a first derivative test, and then this proved that this 0.6 x value was the max population given the circumstances. And then so it is increasing from x equals 0 to x equals 0.6 and decreasing from x equals 0.6 to x equals positive infinity. And then the second derivative graph produced a concave down at x equals 0.6, which verifies the fact that that is the good old max right there. And then I will provide an attached PowerPoint that has all of these if I went through any quick, so you can look at our work. Thanks, Ms. Lily.